Hello, hello. Good morning. What is up? Good morning, everyone. Thank you for joining me here today. Thank you, Juan, for joining this broadcast, the show version live stream. How are you guys doing today? It is a wonderful Saturday morning. Hopefully it's good where you are. Where are you guys coming from today, if you don't mind me asking? Got some dark roast coffee to get me started as we do a little technical discussion today about the CCNP Encore. Now, I just prepped for this live stream yesterday morning, because I wanted to be sure that my lab was working. And the lab is the one thing that can go wrong during a live stream, and it can be devastating. I have my fan going on in the background because I'm recording here in my garage in San Jose, and it can get a little warm with the light on, my laptop running at full speed there, and it's blowing dust everywhere. But thank you for joining me here today. We're going to talk about CCNP. It's been a interesting week, right, for many of us with what is going on around in this country. We've also had to deal with events being rescheduled. So Cisco Live was rescheduled to June 16th or 17th, with DevNet Day being rescheduled to June 18th. And so I'm happy that it's scheduled later in the month, because I was actually busy during the time they originally scheduled. But why don't we start talking about this CCNP topic here? And I wanted to take a look at CCNP Enterprise Core because it's got some wireless topics in it, and wireless is my favorite topic to discuss. There's a lot of great things about wireless, since we all use wireless today, right? We're always connecting with our mobile devices, with our laptops. And so the CCNP Enterprise Core has pushed a lot of different wireless topics into that exam. They do have that specialization exam for wireless, but we have much more detail in the CCNP certification, the Enterprise Core certification. Specifically, the objective that I want to talk about is the describe access point discovery and the join process. So the different discovery algorithms, excuse me, the wireless controller selection process. So we'll talk about that objective specifically. And I have a Cisco 3504 controller, which I could show you right now. Let me share my screen. So here's my controller, right? And I just want to minimize some windows here. This is my 3504. It's running 8.10, as you could see. We do have one access point that's joined to this controller. Just wanted to be sure that it was working properly. Here is its IP address, which, if you look at that, happens to be on the same subnet as, if I can go to interfaces, happens to be on the same subnet as the management interface, which is just a /24 network. And it does have dynamic AP management. So the AP was able to join. You like that internal temperature? I'm surprised that it's holding up and it's not that hot. It should be hotter, I believe. It's sitting to my right. I have a little cabinet down below here, but there's no sufficient airflow. So hopefully it'll hold up. It's been on for a long time. So just so you can see that temperature, it still holds up. But I only have one AP connected to it. So here's my 3802. It's been up for 20 minutes because I did change the network of the IP address of this AP, so it was on the same subnet. Now, the way this lab is built out is we've got my wireless controller. Just draw it out real quick. right? And it's connecting to a switch, and this is a Cisco switch. This is a 3650. It's a compact switch. And off of that same switch, I've got an AP. This AP is the 3802, and it has a native trunk, native VLAN trunk command, which places the IP address, the network for this AP on the same subnet as the wireless controller. And then I have my gateway, which is a Unify security gateway. And this is my router. This is where the gateways land. Now, yesterday, as I was prepping for this live stream, I did run into an issue where my AP wasn't joining the controller at all, and it happened for every single AP that I joined, and it was part of the discovery process. So I ended up doing some troubleshooting during this whole time, and what happened was this AP was getting a /24 IP from my Unify security gateway. It has a DHCP server on this router. The wireless controller is statically set. And if you look at the interfaces of this thing, we'll look at the management interface. You can see you have to set the VLAN identifier, the IP address, mask, and gateway. The problem which took me a long time to figure this out, because I even looked at this page directly, looked at it, stared at the IP address, but what I didn't notice is I had used this mask right here. And because the AP was trying to join, it would not. And I was trying to figure out why that was. And so we'll dive into some debug messages with the wireless controller, because that's what led me to look at this interface here. But because it was not the same mask, the AP was unable to join, right? So this here was on a different mask, but I changed it yesterday to make sure it was also on a /24. So that's my basic lab setup. This is these are both in my garage. This whole let's see, this whole setup right here is in my garage. This is upstairs where my Comcast modem sits, which I have a power inline running between that and my garage. So I get, less than optimal speeds, but hey, it works. All right, so when we talk about wireless controllers, this is what I like to call the traditional way of managing your wireless network. Because wireless controllers, people like to say that it's the old way of doing wireless, but the truth is there's still a lot of controllers out there. They are complex if you've got a large environment, and then when you add redundancy to it, high availability, things can get a little challenging when you try to troubleshoot, or you try to determine where an AP is going to go join, which controller is that going to go to. Now, for this lab, we are going to keep it easy because I only have one controller. There's simply one controller. And you can see if we go to an AP, click on that and go to high availability, you can actually configure your primary controller, a secondary controller, and if you really have one, a tertiary controller. That is one of the methods in which an AP is going to join. All right, so these controller-based APs, they must join to a controller in order to serve clients over Wi-Fi, because the APs themselves are pretty dumb. They don't have a configuration by default unless they are a standalone AP or they're configured in some other way. But these APs, which we'll call like a lightweight AP, they don't hold the configuration. So they get their configuration after they join a controller. They understand, all right, here are the SSIDs I'm going to propagate out into the RF space here. And so here's the primary, secondary, and tertiary controller of an individual AP, this AP right here, which you can configure. Now, when you have an AP that is joining And you can see I have this one AP. It's been up for 25 minutes. It uses something called a CAPWAP tunnel, right? So if we, I'll show you some of the CAPWAP tunnels on a Wireshark capture, as long as I'm going to be able to bring that up. But a CAPWAP is your control and provisioning of wireless access points. That's what that means. And it's a way of, the AP will create a tunnel in which all traffic, data, and also control will go through as it goes back to the controller. What's up, Network Bruh? Thanks for joining. Really appreciate you being here. We were just, having we just chatted a little bit on Twitter about what was going on. But here, I'll head back and talk about the CAPWAP tunnel. Yep, CAPWAP, I remember when I first had to deal with CAPWAP and I did not know. So my journey into wireless was just being thrown into it. I got thrown into a client environment, and they had Cisco 4404 controllers, a couple of them. And at that time, I did not know that APs created a tunnel back to the controller, which meant all the client traffic was tunneled back to wherever that controller was. So even if you had your AP in, say, site A, but the controller lived in site B, all that traffic would go back to where the controller lived, and then the traffic left the controller. That's where the termination point was. That's where you saw that client was out of that port where the controller was connected to on the network. And so CAPWAP traffic, there's data and control, and I never remember these ports, which you should remember for the CCNP Encore, the Enterprise Core exam. It's data is on port 5247 UDP, and control is on port 5246 UDP. And so we'll try to find that in a Wireshark capture through my switch. All right. I do have my AP and controller up on terminal right here. So you can see that there's some messages being sent out. And Network Bro, what model AP joining to the wireless controller? It's a 3802i, which I have right here. I have it plugged in down below. I have a lot of APs, to be honest. This one's a 2802i. The 3802i looks similar to this. It's a little bit bigger than this, a little bit. It's got a heat sink on the back, and you've got different ports that are here on the AP. I am consoled into the AP just so I don't lose my connectivity. And Quantum Delta says, ours is even more annoying. Our client data breaks out locally via Flex Connect, while our management control traffic goes off to our wireless controllers across the continent. Yeah, so you really need a low latency connection for those APs to maintain that connectivity back to the controller. And the Flex Connect, which is another topic I'd like to discuss on this YouTube channel, where Flex Connect, you actually locally drop that traffic to the local switch versus sending it back over across a tunnel, which we can talk about another time. But if we go back to my iTerm, here's my AP. I've got it consoled in, which means I have to occasionally sign back into here. And if we do a show CAPWAP client config, I believe that's the command. Nope. CAPWAP client. Oh, you know what? I'm not in enable mode. That'll always get me. Punch in that password again. Oh, there we go. Share my screen. Always forget to share my screen. All right, so I'm logged into the AP here on the left side. So I have a split terminal here. The left side, that's active. That's my AP, and then I'll switch over to the right side. You can see those colors change. The right side is my controller, the 3504. If we do a show AP summary, you can see I've got one AP right there. That's the AP name. Then if I go back to the left side of where my AP is, we do show CAPWAP. AP or client config. So this is what's currently configured on the access point because it is already joined to my controller. And what I want to do in this lab is actually tear this all apart. I'm going to erase that config that's saved on there because as the AP loses power, it's actually going to store some of this config in its non-volatile RAM. So when it comes back up, it'll actually join to the last joined controller that it knew about. So if I were to reboot this AP, it knows to reconnect back to that controller. So the first thing I want to do is talk about this controller discovery process. There's different ways an AP will find a controller. One of the first methods is using option 43, and this is using DHCP. Now I tried to do this yesterday, option 43 on my UniFi security gateway, but the UniFi system will, to me, it appears to reserve option 43 as a way to control traffic just for the UniFi cloud key. And so when I did try to set up the IP address for the, I don't know if I can show it to you guys. Let me try to show it to you guys. First, let me log into my UniFi system, and I don't want you guys to see my super secret password and all that. I do have two-factor authentication set up, so I'm not too concerned. So this was my first challenge going into UniFi Security Gateway. Now, not many people would set up a Cisco wireless controller and then use a UniFi Security Gateway on their network. It's just not something I think people would do. You would probably either, most people like to keep the same vendor all around. I'm used to working with different vendors mixed together in the same environment, but hey, you do you, you do what makes your network work. But these are the kind of quirks I see when I am running different vendors in my environment. All right, so what I'm doing is trying to log into my UniFi system to show you option 43. Now, here's my infrastructure network, which I place a lot of my network devices on. And I was looking for option 43. So I looked at this here and I said, hey, I don't see option 43 here. Maybe it's under advanced DHCP options. And you look here and you go, I don't see option 43 anywhere here. So I go look at custom DHCP options, and you will see a lot of different options here. If you go to create new DHCP options, and I'm thinking, all right, this should be the right spot to configure that, right? I see all these codes here. That should be option 43. There's a lot of codes. If I scroll up, I go, all right, I'm in the 40s, 40, 41. Where the heck is option 43? It's not there. And so I go back and I realize, looking at this network, there is an option 43 here, and it's actually under DHCP UniFi controller. And if you hover over this informational button, enables DHCP option 43. So I plugged in the controller IP address. But what I didn't see when I was looking at the packet capture, I rebooted my AP, and when a DHCP request, I see the DHCP request go out, I see the offer, but in the packet capture, I did not see an option 43 anywhere. So I'm not sure if the UniFi Security Gateway is looking for something very specific, maybe something very specific to UniFi, and then it pushes option 43 to that UniFi device to say, hey, here's the UniFi controller to go to. So I scratched that option. So just so you know, option 43 is one way in which an access point will find a controller. And in those option 43 settings, you will have to figure out what IP address you're going to put in option 43, which will be sent to the AP, and it'll go, all right, that's where the controller goes. Quantum Delta, we use 3 or 4 vendors, but try not to blend them in the same environment. Yeah, you can run into all sorts of issues blending vendors, and a lot of vendor pointing back at each other when you troubleshoot. Some weird issues coming about, but I'm used to having multiple vendors in the same environment, having to deal with weird problems that sometimes occur, not too much, but as long as you stick to networking standards, open standards, then you should be okay. In my environment, I actually don't use option 43 that much. I like to use the second method, which if you have a DNS server, a controller will look for Cisco-CAPWAP-controller domain, your local domain. And so if, let's say my domain was roeldionisio.com, and that's what was pushed via DNS, then the controller would look for that domain, Cisco-CAPWAP-controller. And with DNS, if you have an IP address set, it'll push that IP for that controller, and that's where the APs go. I like that option because it's easy for me to change the IP address DNS entry. And so if I wanted to push a large set of APs to another controller, I can do that pretty easily. If you have a different domain, you could put certain APs on different domains and point them to that controller on that domain. The third option, which I do have, I think we can show it here on this AP, is a static configuration. The static configuration is really just going into an AP. If you have access to it, it's either the config that it downloaded when it last joined to a controller, so it'll keep that IP address of that controller as a static configuration on the AP. The other way to do this is you can configure the IP address, which I think I just, password in here. Access denied because I can't see what I'm typing. There you go. The other way to statically configure these APs is by just typing in the command in CLI on the AP. So as I'm consoled into this AP, if I want to tell it to go to a specific controller, I do CAPWAP AP, and then you can see here there's a primary base. You can configure the AP's primary controller. You can configure the secondary controller, and you can configure the tertiary controller. So you can do CAPWAP AP primary base, which would be the name, and then the IP address. So 172.16.103.10. So then if you wanted to move an AP, a specific AP, you can do it this way and change the controller itself. If you're troubleshooting for whatever reason, if the AP cannot automatically join to a controller, you can also do it this way. And this is what I did to troubleshoot yesterday when my AP was not joining at all to my controller. What I ended up doing is logging into the AP and configuring it statically with this CAPWAP AP primary base command, and then it joined. And so that kind of helped me understand that there was connectivity between the AP and the controller. It's just something with the auto joining process, the discovery process that wasn't working. And that brings up a good point about APs joining to controllers, is that they need to have that connectivity between them, obviously. And so part of the troubleshooting process is logging into an AP and seeing if you could ping the controller, or logging into the controller and seeing if you could ping the AP, and ensuring you have the right ports open if they're on different subnets and there's a firewall in between. So that's the static configuration portion. The other option after it goes through those attempts is it just does a local broadcast. So it'll send a broadcast message out on the subnet, and if the controller is on there, it'll discover it and send some CAPWAP messages. And yes, Quantum Delta, this is a good way to rescue APs stuck in boot loops. For me, the hardest part is getting that access to the AP if you don't already have it, right? So that's why I like to enable SSH access to these APs for that sole purpose. Otherwise, you're going to have to go on site and then have to console into that AP, which is not the ideal situation. All right, so that's those are the 1, 2, 3, 4 methods. 1, 2, 3, 4. The fifth is just using the last join controller, which is I consider that as part of being the static configuration. So if we look at the AP, I want to look at the AP here and look at its joining process, because we really get to understand how this works. So I'm going to log into my switch, and what I'm going to do is reboot that AP. What I want to do is show you all the different messages that are shown as part of the discovery process, because that is how you really get to understand how the AP is trying to find a controller, what the discovery methods it's going through. And so here I will no shut on the interface in which the AP is connected, and then show you the screen. So here we have now the AP is booting up. I just shut down the interface and brought it back up. You can see it goes through some boot modes. You can see what software is going to load up. And if I go here to my controller, this will time out on the right, and we'll see that AP disappear. We'll find that the DTLS tunnel, which we'll go into, will no longer work. So it's checking the image now, verifying the image is good. It's going to start the kernel. All right. The downside about rebooting the Cisco APs is the amount of time it takes to get to its operating mode. I am not a big fan of how long these APs take to reboot, especially if you have to reboot these APs in a production environment. And then if you're remote, you got to cross your fingers and hope that the AP comes back up. I really like this newer version of the AP image because you can clearly see if something is okay or not okay, right? So it's going to start up a bunch of services, do a bunch of checks, and if something's not running properly, you can actually see that. It's really interesting to see how this works, but maybe you should play some music while this is happening. You see how long this is taking? All right, we got a user prompt, but it's gonna keep going. All right, so it's gonna go by fast. There's a domain configured. It's turning on some radios. That domain was probably the country code. These .11s are for the radios. You can see it's got an IP address. DNS is set. It's on channel 100. Right, so we have no APs on the controller. So it's now negotiating some PoE negotiation to complete in CAPWAP main. AP is in fair condition. All right, that's good. It would really be horrible for this AP to just fail during this lab. I'm not using any IPv6 on my network. So here's these CAPWAP, starting the CAPWAP discovery. All right, it's initializing, it starts the discovery, and it's sending it to the last controller. And it said static config because that was the last controller that it joined. So now we've got AP has joined controller, the 3504. The password was changed. The default password on these APs is just Cisco. And because I have a separate password set up from the controller, it pushed that to the controller. Now if I do a show AP summary here, we've got that configured. So you can see that process when an AP reboots as it was already joined to a controller. It does that discovery, and I'll see if I can scroll back up to find that. I'm consoled in, so this is going to be horrible to go through. I think it's way or I passed it. Here it is. So here's the starting CAPWAP discovery. It already sends a discovery request to .11. So it's got this .11 set up, which is my other controller, which I don't have on. And then it sends it to .10. So it considers as a static config. And then it sends a discovery, a broadcast on the same network. So it sent 3 of them. And then there was a response from 172.16.103.10. All right. And then it sets up DTLS. That's how it securely, through the tunnel, securely sets up that tunnel afterwards to authenticate to the controller. When I said last Quantum Delta, I have actually two controllers at home. I have a 2504 and a 3504. The 2504 is configured as the .11, and that is currently disabled at the moment. Network Bro, yes, on the left, I'm consoled into the AP. I have a console from my laptop to the AP itself, so that way we can see whatever's going on the AP. All right, so there you go. Simple, right? Pretty easy. Now, on the AP side of things, I like dealing with debug messages because this is why I like Cisco, because of how much information we can get out of a device, especially on the debug side of things. And Quantum says if the config AP group RF profile doesn't exist on the old controller, dumps Flex Connect VLANs out the window until human config. You know, those are the things you learn on the job, right? There's a lot of different challenges going into dealing with controller-based APs. I like to look at debug commands, and we could look at debug commands on the AP itself as well. I don't know if it's going to... Doesn't like my password. Why? The AP has a large set of debug commands you can run if you're trying to troubleshoot. There's the ones that are most important are the debug CAPWAP client commands and the debug DTLS client and error commands, because those are what is used to try to join the controller. You can do the same on the controller itself, but what I want to do is actually show. All right, let me set up the part where we actually do some Wireshark capture, because I want to show that you can see a lot of this detail going on. You could, if you're trying to analyze how this join process works, we got to set up something. So what I'm going to do is set up a monitor session. If I remember how to do it, do I have even a monitor session set up? Show monitor session all, which I don't. All right, so it's been a while since I set up a monitor session. So let's say config T. This is my switch, and I'll just show you what version it's running. It's a 3560 CX PoE switch. I have my laptop connected on this port on a different VLAN, my AP on a trunk port, and I believe this is the port for the controller. What I want to do is set up a span port. Monitor session 1, and the source, let's just say the source is the controller. Anyway, we can set up G109. We can actually add the AP interface as well. And then I want to send the destination, all that traffic to my laptop. And I always forget, do show interface status. It's interface 2. So monitor session 1, destination, interface. I always forget the interface command. All right. Take a look at that config. Setting up a monitor session. Basically, I'm going to monitor these source ports, my AP and controller, send that traffic to this interface. And why do I want to do that? Because I want to see the messages between the AP and the controller, get those CAPWAP messages. We'll run some debug commands on here. So if I pull up Wireshark, we shall capture on my Thunderbolt connector and then set up a filter for CAPWAP. So we got that running. We should probably see some traffic. I want to log into here on my AP and erase the config. So we do CAPWAP, AP erase all, confirm. All right, so we got that running. I erased the CAPWAP configuration. We want to run debug. I can never remember this. CAPWAP events enable, debug CAPWAP, packet enable. Now you gotta be careful with these debug commands in a production environment. You don't want to overload your controller, especially if you got a controller running thousands of access points, because you would just constantly see a ton of traffic. It's gonna be hard to see. That must be the DTLS that got torn down. So let's check after this method, after packet number 56. So again, what we're trying to do here is boot up the AP as if it was never been configured to join a controller. The controller, we've run 2 debug commands, debug CAPWAP, events enable, debug CAPWAP packet enable. And we want to see those messages. Actually, we can do, oh, there's some messages right there. Debug, that's actually removing that tunnel CAPWAP errors enable. So any errors, we want to see those as well. So now AP is still booting. If we look back up here, this was deleting the AP, the DTLS connection, because the AP has disappeared because I erased the config on the left side here. And hopefully we can get something good on Wireshark to even further understand what's happening in this environment. It's a good time to sip some coffee. Which controllers are you guys using in your environment, if you are using controllers? And how many of you think controllers are dumb? Is it all about cloud now? Cloud-based APs. Just waiting for this AP to finish booting up. It's still going. AP's in fair condition. All right, we should be able to see some messages coming up soon. We're now looking above packet 341. Here's the CAPWAP state. Hopefully I did my monitor sessions correctly. All right, there we got some CAPWAP controls. Oh, there's some messages. Discovery. All right, it's looking good so far. Awesome. Now remember, I said packet 346 341 was where we wanted to start. Quantum Delta, you've got 20 units in total for Cisco, all running close to capacity, a mix of N+1 and SSO. All right, that's a good setup. What version are you guys running, Quantum Delta? All right, so AP is fully joined to the controller, all right? We've got a good setup here. So first, let's do debug, disable all on the controller. Charles Byron, you're still using controllers and using several Cisco models. All right, I like that. Very cool. So AP on the left, already joined to the controller. Let's look at the controller right now. I'm going to stop my Wireshark capture. I'm going to go back to the controller because we want to see these messages. And there's quite a lot here. So maybe if I can expand this window, there you go. That looks easier to read. So you can see here, after we had rebooted the AP used to be connected to the controller. Then on the AP, I told it to erase all its CAPWAP config. The controller then noticed that the AP has been down for quite a while. So you see this echo timer expiry, which then it goes into disconnecting its existing DTLS CAPWAP control session for that AP. There's a teardown. And then we start looking at, if I'm looking at these timestamps because I just want to ignore all the messages where it tears it down. All right, so there you go. Here's where we start then with the AP joining to the controller. There was a CAPWAP control message received from the AP. That's my AP's IP address on this port. All right. And you can see start of the CAPWAP packet, the control message. It's a CAPWAP discovery request. And here's the model of the AP. Starts going through different messages here with the controller. Some of these messages I never remember what they mean. Like if you were just looking at these messages, you have to understand what they mean and try not to get hung up on specific messages like this. All right, sometimes that doesn't mean much in this case. So here's the discovery request. This is coming from the controller. This is a debug command from the controller output, and it's saying, "Hey, I got a discovery request from this source IP and port." Here are the message elements, AP model, different message elements, which I don't know what these are. Cisco has some documentation on this, but it's very hard to find in my opinion, and I always forget to save it. So here's the vendor specific payload from the AP, right? So that was at 8:16:58. Join priority processing. So it's now starting to look at, all right, let's take a look at the controller. I have a max license of 5 APs that can join. Here's the AP model, the bundle image version that we're running, the AP is running. And here's the controller name. And then here are more CAPWAP control discovery response. So there's the controller responding to that CAPWAP request. There were 2 that the controller received, I believe, and 1 probably to the IP address directly, and then 1 that was a broadcast. And then eventually DTLS starts to be built. And as you can see here, this is also a key for an AP to join. You want to be sure these DTLS sessions are established. So there's a DTLS session established between the AP and the controller, and some more CAPWAP packet messages that we're receiving as part of the debugs that I issued. Now, if you did have any errors, we would see errors here too, because I did run a debug CAPWAP errors enable command. And so there it is. It's joined. Then there's going to be a variety of CAPWAP messages sent between the controller and AP But now let's dive into Wireshark because we can see some interesting information here as well. So I'll start here at packet 815. This is where we see this request. So you can see that the AP actually sent a broadcast request on the network, CAPWAP control discovery requests. Wireshark either doesn't know what to do with this packet or there is actually something wrong with it. There isn't anything wrong with this packet because the controller responds with a CAPWAP control discovery response. So if we take a look at this request again, you can see it is source from the AP to the destination broadcast. Here is the source port 5272, which we saw back on the controller. The controller saw that message. It received the CAPWAP message from that AP on that port. Same thing that is happening here. The destination port is 5246. You can see some of the CAPWAP messages. Here's the preamble. It is a CAPWAP packet. There's the MAC address, the control header. So this is why I like diving into Wireshark and why you should understand how to use Wireshark to really capture what's going on. So that's a broadcast address, right? And then the controller will respond to that request with a CAPWAP control message, a discovery response, as you can see with the source being the controller, destination being the AP. Source port 5246. Remember 5246 in the beginning of the stream where I said the CAPWAP control message is 5246, a UDP, right? So it says UDP right there, 5246. Here are some more details in that CAPWAP response. So let's kind of dive in. Here's the message elements of that CAPWAP response. Remember, if you saw me scrolling on the controller, we saw these packets on the controller, right? So if we go to if I look for descriptor, there it is, right? CAPWAP message element AC descriptor. There's that AC descriptor right there. And we can see active security flags, DTLS policy flags, AC information. We can kind of see diving in here what these CAPWAP messages look like. If you really want to dive in, I think this is beyond the CCNP objective of just describing access point discovery. I don't know if they will actually go into the detail of the packet, which would be great. Here's the CAPWAP IV control IP address, MWAR, payload, lots of good information here, right? And then we talk about DTLS. So there is a certificate that is exchanged. There's certificates on these APs and on the controllers to verify that we are dealing with a Cisco AP. So the AP then sends a client hello. You see these certificate exchanges. They verify the certificate, and that DTLS connection ends up. DTLS is datagram transport layer security. That handshake ends up completing. There's that certificate verify. And after that, then we've got traffic being sent between the AP and controller. So with that, that's pretty much, I'm just looking through my notes to make sure I covered everything. Let me dive back into how I capture the packets. My laptop has a connection to my switch on port 2, which now the connection is closed, but it's okay because we got it up here. My laptop has an Ethernet connection on port 2, and my AP is on port 4. My controller, I know, is on port 9. I didn't even add a description. Shame on me. But you can see I created a monitor session. Just gave it monitor session 1. And if we look up here, I created a source interface of the controller and of the AP. And I said, send whatever traffic you see from those ports, both transmit and receive by default, because I didn't specify transmit or receive, send it to my laptop on port interface gigabit 102. From there, I go into Wireshark and then I capture on that interface. Now I will capture other stuff that's on going through that port, but I filtered it on just CAPWAP. Now, why didn't I filter it in the beginning with with this filter? Because I like to capture everything just in case I missed something. So I will capture everything and then within the capture, filter it through a display filter. So that way I can see, because then now I can go, all right, well, show me everything from 172.16.103.41. So that's everything that sourced from that IP address, the controller, and I can see all of the communication coming out of that AP now. So you can see all these IGMP messages coming out. Now, Quantum Delta has a question. Does the VLAN access matter when you use those commands on the switch? So you're looking at, let me log into my switch. The VLAN access statement on the switch port does not matter if I have configured it to be a trunk, because if it is operating as a trunk, it's not going to use the access statement. And I'll show you. Now, this is diving into some switching details. Let's see here. Show run interface G104. So I think what you're mentioning is this here, right? The switch port access VLAN 103. But I also have these trunk statements. Now, this is just telling the switch port that when it is an access, when it is operating in an access mode, to use this VLAN in that access mode. But because I have issued this command, switch port mode trunk, it is going to use the switch port trunk statements. And you can see that if you go show interface G104 switch port, you'll notice that the operational mode, so the administrative mode is trunk and the operational mode is trunk. Now, if I had switched that to switch port mode access, you will see that the administrative mode and operational mode will change to access. And then you could see which what VLANs are enabled on that trunk. And so these other VLANs are for when I configure my WLAN, which locked me out. Should change these timeouts for my lab. That's when I configure this SSID to a specific network. So these interfaces here are tied to a VLAN. So if I go to controller and then interfaces, you can see I have them tied to specific VLANs. My lab Wi-Fi is on VLAN 120. I have a server net on VLAN 140. So that's pretty much it. So that's the whole video that I wanted to show. A little bit more than what you would probably expect to see out of the CCNP Enterprise Core objective of describe access point discovery and join process. So we did touch upon those discovery algorithms. I don't know if you want to consider them as algorithms, but the different methods is you've got option 43. You could use DNS, static configuration, a local broadcast, last join controller. So there's those discovery processes from the AP perspective. And Stu, you're calling me out. Good practice to keep the port config clean too. It is. So in this case, so if we look at this command, right, this is an interesting command. One of the reasons for, one of the reasons why I always keep this access VLAN on here is there's been a scenario where maybe a device never came back up, because I am configuring it as a native VLAN 103. But if it did end up going into an access mode, right? Maybe somebody else mass config they did an interface range 101 to 12, for example, and they did switch port host. You guys know what switch port host does to all those commands or to all those interfaces? Well, let's say it did happen and it made an access port. Maybe the AP would come back up. I would see it. It would actually be put on the right network, but it's not going to be trunking any other VLAN. So I could actually see that device come back up. And, oh wait, I didn't even share my screen. You could actually see that come back up, right? So even though I have, I sometimes like to put that access command there, because if the port does change to an access port, that device would still come back up on the same VLAN, because I do have a trunk native VLAN 103. It's just, if it did come up as an access port, it would just not trunk the other VLANs on there. And I was saying, like, if somebody did an interface range command and did switch port host and configured all those interfaces as access ports, you would have a problem. But yes, I would definitely clean up configs there, especially in a lab environment. I should probably do it now and go to my controller and create a description and do wires controller 3504, because then you can do interface status and see, all right, that's all my connected device, include connected. That's everything connected. AP, controller. Where did my, what happened to my laptop interface? All my commands are messed up. It's enabled. It's down. What did I do? Should do real well. Well, that's troubleshooting. Different video. Oh, because it's monitoring. Duh. That's another thing. When you're done monitoring, remember to bring down those that configuration. Show monitor session all. Because you could end up maybe overloading an interface with too much traffic, right? Want to be careful with those span sessions. So what I could do is do config T, no monitor session 1, and show monitor session all, and it's gone. So I can it's no longer spanning that traffic to my laptop interface. I can do show interface status, include connected, and my laptop is back there. So we went over describing some of the access point discovery methods. Again, that's using option 43, DNS with Cisco CAPWAP controller as the domain. Static configuration, logging into the AP itself and configuring the controller name and IP address, the primary base. It does a local broadcast on the subnet. Also, the last join controller. So there's that. It has to get an IP address, obviously, so it can connect to the get that connectivity back to the controller. I ran some debug commands to show a little bit more detail from the controller's perspective, so you can see those CAPWAP messages, what ports they were received on, and also ran some CAPWAP messages to see other details. I didn't generate an error, but if I did CAPWAP, debug CAPWAP errors enabled, you would be able to see if there was some sort of error with an AP joining a controller. So maybe the AP was able to reach the controller, maybe it created the CAPWAP tunnel, but maybe DTLS failed, for example. What else did we talk about? The wireless controller selection process. So I didn't dive into that too much, but if there is a mobility domain configured and there's multiple controllers in that mobility domain, it would there is an algorithm there where it selects a controller from that mobility domain. There's a load that is taken into consideration. With option 43, you can actually put more than one IP address in that list, so it can pick from one of those controllers. This is why I like using the DNS entry, because then I can specifically tell an AP to go to a controller. Or when you do configure if you've got multiple controllers and the APs are joining to random controllers, for example, and it's not that random, it's just part of the algorithm, you can configure their primary and secondary controllers and move them to their assigned controllers and make things more deterministic, where you say, all right, all these specific APs, this is their primary controller, If the primary controller is gone, they fail over to the secondary controller or tertiary controller. So that's pretty much it, guys. I want to thank you for joining me here on this live stream. It was a pleasure. I hope you guys have a great day, a great Saturday, wherever you guys are coming from. I hope you enjoyed the live lab with my controller and AP joining process. I can do a couple more labs with this. I have a lot of APs, so maybe I can join a bunch of APs, do some simulations of primary, secondary controllers. But hope you also enjoyed the Wireshark capture that I did with that CAPWAP process. So if there's any other topics you want me to try to dive into with my live lab, let me know in the comments below. If you enjoyed this lab, give me a like on that YouTube video, but I greatly appreciate you joining me here today, especially you, Stu. Thank you for joining me here on my live stream as I joined you and Ekahau on your guys' webinar, so I really appreciate that. Thank you, Quantum Delta, for joining me here, and also Charles Byron. Thank you for joining me on this live stream. I greatly appreciate it. I want to wish you guys a happy Saturday. Enjoy your day. I'm gonna finish up my coffee before it gets too cold, and yeah, Stu, I'll take a look at some Flex Connect lab configs. I can put my AP upstairs on a different switch, and then put my controller down here on the Cisco switch, and we can try to simulate some of that Flex Connect stuff. Network, bruh. Thanks for joining me here on the live stream. Really appreciate it. All right, guys, you have a good one. I will see you on the next live stream.